Welcome back to the video homework guide, and in this video I will continue to solve the homework problems, and the topic that I'll be working on today is implicit derivatives. So for the questions in this section, anytime you see the variable y, you will have to take its derivative, and the derivative of y will be y prime. If you see the variable x, the derivative of x will be just 1. Okay, so we have to be very careful with going back and forth between x and y for some of the problems in this section. Okay, let's take a look at example number 1 here. I see d over dx, so d over dx just means take the derivative. And if I take the derivative of this expression right here, the 3 would come onto the 4 using the power rule. So 4 times 3 is going to be 12, and then the y would remain. And then the 3 would now lose its power by 1, so 3 minus 1 is going to be 2. But then the chain rule states that you need to take the derivative of y, and the derivative of y will be y prime. So my final answer is going to be 12y squared times y prime. Okay, let's move on to question number 2 now. And for question number 2, I see a radical sign right here. So step number 1 is we should change that radical sign to a power. So that's going to be y to the power of 1/2, and then this minus sign will tag along. If I want to take the derivative, I would use the power rule, and this 1/2 would come to the front. So it would be negative 1/2 y. And then I would subtract 1 on the power here. So I'm going to subtract 2 over 2. So 1/2 minus 2 over 2 is negative 1/2. And then the chain rule states that I need to take the derivative of y, and the derivative of y is going to be y prime. All right, so in order to clean this up, this part right here I can write as 1 over the square root of y. And then this 2 right there, I can just transfer that downstairs to the denominator, and then the minus sign would tag along, and then the y prime would just be at the tail end here. And if you want, you can just erase the 1, and then 1 times y prime would just be y prime on the numerator, and that would be your final answer. So this is your final answer right there. Okay, moving on to question number 3. I have some old work on the side here, so I'll erase that. So for question number 3, I need to take the derivative of 1 over y. And I will start off that problem by writing that as a power. So that's y to the power minus 1. And if I want to take its derivative, the power rule states that the minus 1 would come to the front. So it would be minus 1 times y. And then I would subtract 1 from the power here. So this would be negative 2. And then the chain rule states that you need to take the derivative of y, and the derivative of y is going to be y prime. All right, that answer is okay, but you should definitely feel comfortable with cleaning this answer up. So this part right here in the box, that's going to be 1 over y squared. And then this minus sign here would just tag along in front. And then this y prime, I guess you can put it on the outside there, but y prime times 1 is going to be y prime all over y squared with the minus sign out in front. So this is your final answer. This is your final answer right there. Okay, let's move on to question number 4. For question number 4, I need to take the derivative of this product, so I need to use the product rule. So for this question right here, I'm going to just change colors here, and here's a 2x, and there's also a y prime. All right, so I need to take the derivative of the yellow term first. So the derivative of 2x is going to be 2, and then I times that by the green term, which is y squared. And then the product rule states that I need a plus sign. And then I would write out the first term, which is just 2x, which is the yellow guy. And then you take the derivative of the green term. All right, so there's a 2 here, so the 2 would come out in front times y to the power 1. And then the chain rule states that you need to take the derivative of y, which is y prime. All right, so that is the derivative. And then you should do your best to clean this up. So this expression right here would just be 2y squared. And then over here, 2 times 2 is going to be 4. So that's going to be 4x. This is just a y, so 4xy times, and this will be y prime. So that right there is your final answer. Okay, let's move on to question number 5. And there's some little notes over here, so I'll erase that. For this question right here, I think you could just, apply the quotient rule, and if you apply the quotient rule, you should be able to, get yourself the right answer here, and don't worry about simplifying. So the quotient rule states that you take the denominator and you write that on the numerator, and then you would take the derivative of the numerator, which is 3x squared. And then the quotient rule states that you need to subtract the top, which is x cubed, times the derivative of the denominator, which is y squared. So the derivative of y squared is 2y. And then you would take the derivative of y, which is y prime. So once again, the derivative for y squared is going to be 2y, and the derivative for y is going to be y prime there. Okay, and then we would divide the whole thing by the bottom squared, so y to the power 2 squared is going to be y to the power of 4. Okay, so that should be it. I don't need to simplify the answer anymore, and let's move on to the next set of questions. Alright, so for example number 2, I need to use implicit derivatives again to find the derivative, which is dy over dx. And now I have x squared minus y squared equals to 9. Okay, so let's take a look at x squared there. I mean, what's the derivative of that? The derivative of that is just 2x minus. And then what is the derivative of y squared? Well, we just talked about that. That's going to be 2y times y prime equals, and the derivative of 9 is going to be 0. Okay, after that, I'm going to take this term right here in yellow, and I'm going to move that to the right hand side. So I'm going to move that over here. If I move that to the right hand side, I get 2y times y prime, and then I have just I just have 2x on the left hand side. And my goal is I want to isolate for y prime because that means derivative. So that means I need to divide both sides by 2y. And I'll divide that side by 2y. This 2y and that 2y, that cancels. And then on the right hand side, I just have the y prime now. So that just survives. And then the 2's will cancel over here. And now I have x over y. So y prime equals to x over y. That's the final derivative. Okay, let's move on. Question number 3. All right, so for question number 3, more implicit derivatives. I need to find y prime isolated, and then that would be my final answer here. All right, so let's take a look at x squared here. The derivative of that is going to be 2x. And then there's a minus sign. Now over here I have a product, x times y, but since there's a minus sign in front, I'm going to put a green bracket to kind of make sure that the negative sign doesn't affect the final answer until the very end. Alright, so if I want to take the derivative of x times y, I need to use the product rule. So what's the derivative of x? The derivative of x is just 1, and that would multiply onto the second term, which is y, plus, and then the product rule states that I need to write the first term, which is x, times by the derivative of the second term. Now the derivative of y is just y prime. Alright, so that's the complete product rule there. I'll close the bracket, plus, and then what's the derivative of y squared for the third time? That would be 2y times y prime equals to the derivative of 6. The derivative of 6 here is just going to be 0. Okay, so eventually my goal is I need to isolate for the y primes. Alright, so I might have to do a little bit of algebra and distribution before I can get y prime by itself. So I will now distribute the minus sign into the brackets, and my next line will look like this. Will look like 2x minus y minus x times y prime plus 2y times y prime equals to 0. Okay, so after that, let me just switch colors here. Right, so sorry, I'm just going to highlight the y primes here because the goal is to get the y primes by itself. And in order to do that, I'm going to take the, well, I'm just going to leave the 2x and the y on the left-hand side. And I will take all of this and move that to the right-hand side. So that's going to be x times y prime minus 2y y prime. Okay, so all I did there was I just grabbed these guys and I moved these terms to the right-hand side. And after I do that, I'm going to factor out the y primes here. So that's going to be y prime, open bracket. And in the open bracket, I would have x minus 2y. And then I would close the bracket there. And then I would have 2x minus y on the left-hand side. And then I can divide both sides by x minus 2y, divide that by x minus 2y. Those would cancel, and I would get y prime equals to 2x minus y over x minus 2y, and this would be my final result after simplifying and getting all the terms on one side. All right, I'm now moving on to question number 4. And for question number 4, you know, it's similar to some of the other previous problems that we've done so far. So I will start with x cubed. The derivative of x cubed is going to be 3x squared. And then there's a minus sign. And I will now put a red bracket next because I need to take the derivative of this product right here. So I need to use the product rule to complete that. So I would go ahead and take the derivative of 2x first. The derivative of 2x is going to be 2 times y. And then the product rule states that you need to add. And now I can now write the 2x next. And then ask yourself, what is the derivative of y? And the derivative of y is just y prime. Alright, so that's the product rule right there. I will finish that off with a bracket, and then I need to add the derivative of y cubed, which is going to be 3y squared, and then you times using the chain rule, and that would be y prime equals to the derivative of 0 is now going to be 0 on the right-hand side. Alright, so after that, I will now distribute the minus sign to into the brackets. So this would be negative 2y minus 2xy prime, and then the 3x squared would remain in front there. And then I would have the plus 3y squared times y prime equals to 0 to finish off the line. Alright, so my goal is I want to get the y primes together here. So the y prime here and the y prime there in yellow, I need to get those all on one side and factor that out. So I can just move the y primes to the right hand side of the equation. So if I move this guy to the right hand side, I would get 2xy prime. And then if I would move this guy to the other side, I would get negative 3y squared times y prime. And then on the left-hand side of the equation, I still have the 3x squared minus 2y. Okay. All right, so now that I've got the y primes all on one side, I can highlight them, highlight the y primes, and I can factor those out. So if I factor out the y primes, I would get 2x minus 3y squared. And on the left-hand side, I have 3x squared minus 2y. And finally, in order to completely isolate for the y prime, I can now divide by 2x minus 3y squared and divide this side by 2x minus 3y squared. Those guys will cancel, and now I'm left with y prime, and my final answer is, just rewriting this one more time, this would be 2x minus 3y squared.